We know that rationals involve fractions and variables. On the left, we have two examples of rational expressions. On the right, we have two examples of rational equations. What do you think the difference is between an expression and an equation? Well, hopefully you can see that on the right-hand side, we have equals and then a value. We have equals and then a value. So if we have an expression, there is no equal sign. All we can do is simplify it down. If we have an equation, now we can actually get the value of the variable that would make this a true statement. So what is the value of x, or what are the values of x, that would make this equal to 1/12? What are the value or values of x and y that when we substitute them back into the second equation, the left-hand side is going to equal the right-hand side? Now, for the purposes of this course, we're going to deal with one variable equations. So we're looking for the values that are now going to make the left-hand side equal to that right-hand side. You have solved multiple equations in the past, so we're going to put all of your skills together. Now, you want to recall that if we have a linear equation, it's going to be degree 1. So that means the highest exponent on the variable is 1. So if you take a look at the variable, it is an exponent of 1 on that x. If you take a look at the variables, the highest exponent on any of those terms is going to be a 1. The goal when you're solving a degree 1 equation is always to isolate the variable. So we want to get that variable by itself. So the first thing we're going to do if we see something like this is we're going to get rid of the brackets by distribution. We're then going to do opposite operations to try to isolate x. So we're going to bring negative 35 to 0 by adding 35. What we do to one side, we do to the other, Algebra 101. Then we're going to divide out the 15 on the left to get 1x, and then we're going to divide out the 15 on the right to get a value of 16/3. And we want to leave it as an exact value, so we're going to leave it as a fraction. Now, the beauty with algebra is you're going to know if you're right or not. If you substitute this back in, 3 times 16/3 is 16, 16 minus 7 is 9, 9 times 5 is 45. So substitute it back in, check, does the left side equal the right side? Now, if we have variables on both sides, you want to move them to one side. I tend to go with the smaller coefficient just because we avoid negatives, although it doesn't really matter. So we're going to get 2x on this side, and then to isolate this variable, because I see this is degree 1, I'm going to bring this term to 0 by subtracting 2. What we do to one side, we have to do to the other. So on its like term, negative 5 minus 2 is negative 7. 2 divided by 2 leaves us with 1x, and again, we have a value of negative 7/2. You can substitute it back in, and you're going to check, does the left-hand side equal the right-hand side? If it does, that is the solution to the equation. Now, if we take a look at our equation and see that we have a degree 2 equation, that tells us it's a quadratic. So again, you're looking at the exponent on the variables. It's the highest exponent that determines the degree of the equation. So even though this is a 1, this is a 2, so my highest one makes it degree 2, that's a quadratic. In order to solve a quadratic, remember, we have to move all terms over to the side where the squared term is positive. So I can see that right now I have a positive coefficient on my square term. So that means that we're going to subtract 18 to bring this to 0, and then there is no constant term on the left, so I'm just going to have minus 18 right there. And you have to put equals 0. That's what makes it an equation that allows us to solve this. Now, you can solve it by graphing, but the algebraic ways which we're going to have to use are factoring or the quadratic formula. So I would check first of all if it factors. If it does, go with that. If you need the quadratic formula, there we go. Check first to see if there's a greatest common factor that we can remove. So we can see that 3 is divisible into all 3 of those terms. And then again, if we distribute the 3 back, we're going to end up with what we had. So we can check to make sure that we've done that correctly. And then because we have a trinomial, we're going to multiply a and c together. So 1 times negative 6 is negative 6. We're looking for those two numbers that multiply to get negative 6 and add to get the value of b, which is that 1. So I can see that my numbers are 3 and negative 2. So we're going to set up our two binomials. And then remember that factoring is the opposite of foiling. So we're creating those brackets. X times x gets us back to x squared. So now we're going to say x times what gives us one of those values, and because this is a 1, it doesn't matter. We can put one of those numbers there. So if I put the 2 there, that one's good. Now my inside product, x times what, is going to give me that 3 value. I can see it's a 3, and then the last term is a check. 3 times negative 2 is going to give us negative 6. Set each factor equal to 0, and when we do that, we can see the factor that will make this 0 is negative 3. The value of x that will make that 0 is positive 2. Then, again, always check. If you substitute in a negative 3 squared is positive 9. 9 times 3 is 27, so this term has a value of 27. Negative 3 times positive 3 is negative 9. 27 minus 9 is 18. That solution works. Put in the 2. 2 squared is 4 times 3. That term has a value of 12. 2 times 3 is 6. 12 plus 6 is 18. We know that solution is also correct. Not every quadratic is factorable. Some of them, where you have irrational roots, we cannot factor, where we have to then use the quadratic formula. So again, you can take a is the value in front of the squared term, b is the value in front of the x term, c is your constant term with no variable. So you could use 3, 3, and negative 18, or recognizing that you have a greatest common factor, you could pull it out and use a is 1, b is 1, c is negative 6. The numbers are going to be a little smaller and easier to work with. Substitute into the quadratic formula, and then again we want to simplify that radical. The square root of 25 is a perfect square. That tells you that those roots are going to be rational numbers, so you want to simplify down until we get fully simplified. So again, we're going to end up with 2 and negative 3. Substitute them back into the original equation, make sure the left side equals the right side. Now that was super fast because we spend so much time in grade 11 dealing with quadratic equations and then so much time in previous years dealing with linear. Those are the background skills we need in order to be able to solve rational equations. Like most things in mathematics, there is a procedure we're going to follow, and it begins with factoring all denominators and numerators. So that's the same whether we have an expression that we're simplifying or an equation that we're solving. In my particular rational equation, I can see it's equal to a value. None of those are factorable because every term is a monomial. So I'm done that part. My lowest common denominator, so when I take a look, my coefficients are 6, 4, and 12. The smallest number they will all divide into evenly is 12. And then in terms of the variable, I have an x squared and an x. The smallest variable they will all divide into evenly is x squared. So that's my lowest common denominator. And then I can also see that that means x cannot equal 0, otherwise my denominator is 0, which just isn't possible. So my non-permissible value is crucial here because we're going to now come back to this in the last step. Now I need to figure out what my numerators are. So I'm going to take a look at my fractions and I'm going to say, okay, 6x squared, what did we multiply that by to get to 12x squared? And we can see that it was 2. So I'm going to do the same thing to the numerator to keep it equivalent. And that gives me a 6. In my next denominator, I have 4x. I'm going to say, what did I multiply that by to get to 12x squared? And we can see that we multiplied by 3x. So we're going to multiply by 3x again to keep it equivalent. And that gives me a numerator of 3x. And then in the last one, 12 times what gives us 12x squared? And we can see that we multiplied by x squared. So we're going to multiply the numerator by the same value, again to keep it equivalent, leaving us with x squared. Now, step 3 says we're going to eliminate the denominators. So we're going to take a look and we can see that every denominator is 12x squared. So what we're now going to do is we're going to multiply every term by 12x squared. And when I do that, we're going to end up canceling out the denominator with that 12x squared, leaving us just with the numerators. So we have 6 plus 3x equals x squared. So what you want to do when you get down to this step, if the denominators are balanced, you're essentially dropping them and we're left with the numerators. This is why this works. So imagine that we have 1/4 of an apple. If I multiply by the denominator, so I've got 4 on the bottom, I multiply by 4. If we have 4/4 of an apple, we have 1 whole apple. So 4 times 1/4 leaves me with 1 whole. We have to do that to all terms to keep it balanced. So once the denominator is balanced, we are essentially dropping it. Now you're going to take a look and say, what degree is this equation? And I can see that it is a degree 2. That makes it a quadratic. So if it's a quadratic, we need to move all terms over to the side where the squared term is positive. And just watch your signs. Every time we cross the equal sign, the sign is changing. So we have a negative 3x and a negative 6. Now factoring is by far the fastest way to solve a quadratic. So check. If we multiply a and c together, so we have 1 times negative 6, we end up with negative 6. And then we want 2 terms that add to b, which is negative 3. Are there 2 numbers that multiply to negative 6 and add to negative 3? In this case, there are not, so you have to now use the quadratic formula. Because my terms are lined up already, I can see that I have A is 1, B is -3, and C is -6. So I've just kind of listed those on the side. And then using that quadratic formula, I've substituted in. Now it's really important that B is in brackets. This is a negative value. -3 times -3 is +9. So we're going to have +9, and then you can just enter this whole piece into your calculator. But again, you have to make sure you put that in brackets, and we should get a radicand of 33. This is an irrational root. We're going to have one solution of 3 plus the square root of 33 divided by 2, and the other solution is 3 minus the square root of 33 divided by 2. So we have now finished part 1 of the last step. We've solved the equation, but this is crucial. There's two things we have to check. Number 1 is we're going to check the non-permissible value. So x cannot equal 0. If you got a solution of 0, you would indicate that's an extraneous root. It's mathematically correct, but we cannot have it. So you're going to check your solutions against the non-permissible value first. And then the second thing we're going to do is we need to substitute this back into the equation and check, does the left side equal the right side? Okay, we have to do this one at a time. So I'm going to begin with my first solution here. And it's really important that you either enter the numerator and then press equals or bracket the numerator so that your calculator knows we're going to divide this entire value by 2. So I've gone ahead and put this in brackets, divided by 2, and that's the value of my first solution. It's going to keep going because it's irrational. And then remember, we're going to press store as the variable and then enter. Now we have to put this equation back in, and again you got to watch your brackets. So we're going to bracket the first equation and we're going to go 3 divided by, now we're going to bracket the denominator. So we're going to go 6 and then times the variable squared, and then we're going to close the bracket on the denominator and close the bracket on the first fraction, plus bracket the second fraction, 1 divided by, bracket the denominator, 4 times the variable. Every time you press X, it's putting that value in there. Close the bracket on the denominator, close the bracket on that second fraction, equals. So my left side has a value of 0.08, etc. Now I want to check, is that equal to the right side, which is 1/12? So we're going to go 1 divided by 12, and we're going to see, yes, they are equal, so that means this first solution works. Now we're going to start over. We're going to do the second one. So we're going to go now 3 minus the square root of 33, and you're going to probably have to arrow out of that bracket, close the bracket, or arrow out of that radical, close the bracket, divided by 2 equals, or enter, and now we're going to store that as our variable and enter. And now we got to do this again. So we're going to bracket the first fraction, 3 divided by, bracket the denominator, 6x squared, close the bracket on the denominator, close the bracket on the first fraction, plus bracket your second fraction, 1 divided by, bracket the denominator, so we're going to have 4x, close the bracket on the denominator, close the bracket on that fraction, and we end up with a gain, and you can always double check if you can't remember, but that is equal to 1/12. So we know that now this is verified, that second solution is also correct. One quick note, if you're using the TI-83, you'll notice that when you press the square root sign, a bracket pops up there. So what you're going to have to do is close the bracket on the radicand and then close the bracket on the numerator. That verification step is a little bit of time, but so very crucial. So when we've substituted them back in, I know that I have 2 solutions, both of them work. And again, check the non-permissible value first. You can avoid having to do a lot of extra work that way. Let's try another one here. So I can see that this time I do have binomials. So I'm going to bracket those binomials first, and then I'm going to see if they're factorable. So I don't have a greatest common factor in either, and this is not a difference. This is not a perfect square, nor is that. So there's no way I can factor them. So the next thing we're going to do is determine the lowest common denominator. Now we want to remember that this one, if we don't see the denominator, is over 1. So we're going to get that set up first. I need one of each of these binomials in my common denominator. And so then I'm going to say, okay, n minus 3, I had to multiply that by n plus 2 to get my lowest common denominator. We're going to do the same thing to the numerator to keep each fraction equivalent. I multiply this denominator, n plus 2, by n minus 3. I do the same thing in the numerator, and this is a minus. So we're going to have minus 2 and then times n minus 3. And then because this is a 1, I had to multiply by n minus 3 and n minus 2. I'm going to do the same thing with the numerator. And then I can see that in terms of my non-permissible values, n cannot equal 3. That would make that factor 0, and n cannot equal -2. So I have two non-permissible values, and because my denominators are the same, they're all common, it's going to be common to all. Now, in order to eliminate the denominators, once each denominator is balanced, we're essentially multiplying by n minus 3 times n plus 2. All three fractions, we're basically dropping the denominator. Now we're back to previous years where we have an equation we're going to solve, and I'm going to begin by getting rid of these brackets by distributing that term in front of it. And then when we have a binomial times a binomial, I need to FOIL that piece out. Okay, so I've now eliminated all brackets, and I'm going to combine my like terms on each side. And then I take a look and I can see that this is a degree 2 equation because that squared is on the variable. That's my highest degree. So because it's a quadratic, I need to move everything over to the side where that squared term is positive. So because it's positive already, I'm going to minus 4n from the n term. I'm going to minus 15 from the constant term, bringing my one side to 0. Because factoring is the easiest way to solve a quadratic and the fastest, I'm going to quickly check. It is a trinomial. There's no greatest common factor, so I can't remove that. If I multiply 1 times -24, I get -24, and my b term is -5. Are there two numbers that multiply to -24 and add to -5? And there are. So I'm going to set up my binomials, and I'm going to factor this. And then again, what times what gets us back to the first term. And then we want 1 times a number to get one of those factors. So you can see we can put in either of them will work. And then 1 times the other number is going to get us the second one. The last term is a check. Now, you have to actually solve this. So we're going to set each factor equal to 0, and we can see that when n is 8, that factor is 0. When n is -3, that factor is 0. And again, there's two things you have to do now. We have to verify to make sure that this is right. So we're going to go back up here, and we're going to check against the non-permissible values. So 8 and -3, those are both okay. This is +3, but that's okay. That's not -3. And then we're also going to substitute back in, and we're going to see, does the left side equal the right side? Because these are whole numbers, you may want to just do this mentally, or you can store them on your calculator. But I am just going to tell you for the sake of time that when you put them back in, the left side equals the right side on both. There are two solutions for this particular equation. So let's try one last example. Step 1, factor all numerators and denominators if possible. I'm going to begin by bracketing any binomials, and then we're going to check if we can factor them. Once everything is factored, we're going to take a look at our denominators. We're going to determine the lowest common denominator and write equivalent fractions. When I look at my denominators, I have one monomial. So that one monomial is going to be part of my lowest common denominator. And then I can see that I have a y plus 4 and a y plus 4. So I'm going to need a y plus 4, and I'm also going to need a y minus 4. So there are 3 factors that make up each denominator. And then we're going to say to get from our original denominator to our new lowest common denominator, I can see that I multiplied by 4. So I'm going to multiply by 4 up top. 8 times 4 gives me a new numerator of 32. Now this fraction is equivalent to this one here. We multiplied the numerator and the denominator by the same amount. To get from here to here, I can see I started with a y plus 4 and I have a y plus 4. I needed to multiply by 4 and y minus 4. So I'm going to multiply 1 by 4 and y minus 4. And then I had a 4. I still have a 4. I had to multiply by those two binomials. So I'm going to multiply 1 by those two binomials, ending up with that. And then there's no variable in this 4. I can see that I cannot have a -4 and a +4, so I have two non-permissible values. Now, once my denominators are balanced, we're going to eliminate them. And at the same time, I'm going to distribute that 4, and I'm also going to FOIL that out. All right, so we end up with this. I'm going to combine my like terms on each side, and when I do that, we get 4y plus 16, and then I can see that this is a quadratic because I have an exponent of 2. It's a degree 2 equation on that variable. Because it's a quadratic, I'm going to move everything over to the side where my squared term is positive. So everything is coming over, minus 4y, minus 16, so -16 minus 16 gives me -32. Now I can either use the quadratic formula or factor. Factoring is the fastest, so let's take a look. It is a trinomial and there's no greatest common factor. So if we multiply a and c, we're looking for two numbers that multiply to -32 and that add to the b term of -4. And we are in luck because we have -8 and +4. If you're not sure, go off to the margin and start listing all your factors and see if there's any that work. I'm going to set up my binomials, and then we're going to say, okay, what times what gets us back to that y squared, and we know that's going to be y times y. Now think about foiling, we're going to do the outside. So 1 times what gives us one of those numbers, and because it's a 1, it doesn't matter what we choose, so let's maybe do that one. And then the inside, 1 times what is going to give us that other factor of 4, and then the last term is a check, is 4 times -8, -32, and then just quickly foil this to make sure you've done it correctly. And now you're going to set each factor equal to 0, and we are going to solve for the solution. And now we have to verify. So you can see y is equal to -4, but -4 is one of our restrictions. So that means it's mathematically correct, but we can't actually have that. So what we're going to do is we're going to just cross it out, and we're going to indicate that is an extraneous root. It's not going to be a solution. Now, 8 is our second solution. That's okay with the non-permissible values, but now we actually have to put this back in and make sure that the left side equals the right side. So you can either do it on your calculator, or you can go through mathematically and do it, but I will just tell you to save some time here. 8 is going to work. One solution to that equation.